Electricity is often explained in terms of flow, as electrons flowing through a wire, just like water flowing through a pipe. It's a nice illustration, easy to remember, but it's not quite correct. Electricity is actually a moving charge, not moving electrons. It can involve moving electrons. It can even involve moving protons, but that's a different story. Even when there are electrons moving through the wire, the charge moves down the wire much faster than the electrons do. To understand how that's possible, think of the water analogy. Imagine a long pipe filled with water. When you turn on the faucet, water starts coming out at the other end almost immediately, as if it had traveled down the pipe at nearly the speed of light. But it didn't. One little bit of water pushed the next little bit of water, which pushed the next, and so on until the little bit of water at the other end came out of the pipe. Meanwhile, that first little bit of water is still in the pipe, moving along at a much slower pace. It's the same with electricity. Scientists refer to this as electron drift because the electrons move so slowly. With a 1 amp current in a 1 millimeter wire, the electrons circulate at the rate of 8.4 centimeters per hour. A snail can move faster than that. But what starts the electrons moving in the first place? Well, as it turns out, every atom in the universe is made up of charged particles, positively charged protons and negatively charged electrons. And without touching, they all exert an invisible electromagnetic force on each other. As you know, like charges repel each other. Electrons push away from other electrons. Protons push away from protons. Opposite charges attract. Electrons and protons are drawn toward each other. When the negative pole of a magnet is brought up close to a copper wire, it pushes the electrons away, and they start moving down the wire. If a moving magnet can move electrons down a length of wire, then a constantly rotating magnet can keep the electrons constantly moving. That's how a generator works. Except in a generator, the magnet is stationary and a coil of wire is constantly rotating within the magnetic field. It has the same effect. A battery is another way to get electrons moving. Because of an electrochemical reaction that takes place inside the battery, a strong positive charge is built up at one end of the battery with a strong negative charge at the other end. Given a path, a conductor wire, the electrons at the negative end, wanting to push away from each other, will leave and start drifting around the wire to the positive end. It's like a rock rolling downhill. Of course, they don't stop and start piling up at the positive terminal. They keep traveling through the battery, but now they're moving toward the negative end. Pushing negatively charged electrons toward the negatively charged terminal takes work, since the negative terminal is pushing back. It's like pushing a rock uphill. The energy to accomplish this comes from the electrochemical reaction in the battery and will continue until the battery is exhausted. It's important not to get confused about the direction of the current. Outside the battery, the electrons are traveling from the negative terminal of the battery to the positive terminal. However, in the early days of electricity, the Benjamin Franklin days, it was thought the electrical charge flowed from the positive terminal to the negative terminal. So even though the electrons are moving this way, the current is always said to be flowing that way. It's always described that way, and this is no time to challenge 200 years of history.